This question has to do with percentage purity. Try to answer the question yourself first. Pause the movie until you've done this. Seashells are made largely of calcium carbonate, but they don't consist only of calcium carbonate. They also consist of other chemicals which we could call impurities if we wanted to. This question asks us to find out what fraction of a certain sample of seashells is calcium carbonate. In other words, what is the percentage calcium carbonate purity of these shells? To do this, we need to know the mass of calcium carbonate that is inside the shell sample, as well as the mass of the entire shell sample. We then multiply this fraction that we get by 100 to convert the fraction into a percentage. We're told in the question that we had 5 grams of powdered seashells. This 5 grams is the mass of the entire shell sample. It contains both calcium carbonate and the impurities inside the seashell. We're then told that this shell sample is reacted with 500 centimeters cubed of the diluted HCl from the previous question. Somehow we need to use this information to help us to find out how much of the 5 grams of seashell was actually calcium carbonate. How many grams of calcium carbonate are there in this shell sample? How do we do this? The question goes on to tell us that the excess HCl is then titrated. This word excess tells us that there is more HCl in that 500 centimeter cubed HCl than what is needed to fully react with the calcium carbonate in the shell. How much HCl is in the 500 centimeter cube diluted HCl solution? We've already calculated this. 0,125 mole HCl. Look back to the previous question to remind yourself of how this was done. So now we know that 0,125 moles of HCl is more than enough to react with whatever mass of calcium carbonate is in the shell. So we start with an initial amount of HCl. Some of this is needed to fully react with the calcium carbonate in the shell sample, but there is more than enough HCl for this, so some is left over at the end. That which is left over at the end is what we call excess. If we could find out how many moles of HCl is needed to react with the calcium carbonate, then we could find out how much calcium carbonate there is. But how do we do that? Well, since we know the amount of HCl we had at the start, if we could find out how much HCl is in excess, then we could calculate how much HCl must have reacted. The question goes on to give us our way of finding out how much HCl is in excess, because it tells us that this excess is titrated with 140 centimeters cubed of a 0,2 mole per decimeter cubed sodium hydroxide solution. In other words, that excess HCl is placed in a flask with an acid-base indicator in it, maybe universal indicator. The indicator will show that it's acidic. Then, a 0,2 molar sodium hydroxide solution is placed in a burette and added bit by bit to the HCl until the indicator turns color to show that the end point of the titration has been reached. So the universal indicator in this case would turn green. At that point, the titration is stopped. No more drops of sodium hydroxide are added. At that point, we measure what volume of sodium hydroxide we had to add to reach this point. The question tells us what that is. It tells us that we had to add 140 centimeters cubed of sodium hydroxide to reach this point. 140 centimeters cubed is 0,14 decimeters cubed. How many moles of sodium hydroxide is that? We know that N equals C times V. We substitute values. Note how the unit decimeters cubed cancels out and we're left with moles. 0,028 moles of sodium hydroxide. That's how much sodium hydroxide was needed to neutralize the HCl that we used. So how can we use this to tell us how many moles of HCl were present? From the equation showing how sodium hydroxide and hydrochloric acid react, we know that the reaction ratio is 1 mole sodium hydroxide for every 1 mole HCl. Therefore, if we know that 0,028 mole of sodium hydroxide reacted, then from this, what can we conclude about the amount of HCl that was needed to react? It must also have been 0,028 because they react in a ratio of 1 mole to 1 mole. So now we know that the hydrochloric acid that we used in this titration contained 0,028 moles HCl. And remember that this was the amount of HCl that was in excess from the reaction with the shells. Remember that right at the beginning, we started with a certain amount of HCl, and some of this reacted with the shells, and some of it was left over. In other words, some of it was in excess. And now we know how much was in excess, 0,028 mole. Previously, we had asked ourselves this question: how many moles of HCl in excess? Now we know the answer, 0,028 mole HCl in excess. But why did we want to know how much HCl was in excess? So that we could use it to calculate how much HCl reacted with the seashells. How do we do that? There's another piece of information that we need first. What is it? We need to know how much HCl there was at the start. And we do know that. We calculated it right in the beginning. 0,125 mole. So if we know that there was 0,125 mole HCl in the beginning and 0,028 mole of this was left over at the end unreacted, then how much must have reacted? If you don't yet see how to get this answer, then try to create an equation from this situation. We start with a certain amount of reactant. Some of this reacts and some is in excess. How are these amounts related? The initial amount of reactants equals the sum of the amount that reacts and the amount that is in excess. We can rearrange this formula to make the amount that reacts the subject of the formula. The amount that reacts equals the initial amount of reactant minus the amount that is in excess. We know that the initial amount of HCl was 0,125 mole, and we know that 0,028 mole of HCl was in excess. So how much reacted? We find this by subtracting the excess from the initial amount. 0,125 mole minus 0,028 mole. From this we know that 0,097 mole of HCl must have reacted with the calcium carbonate in the shell sample. How does this help us to find the percentage purity of the shell sample? Remember that this HCl will only react with the pure part of the shells. In other words, with the calcium carbonate that is inside the shells. The HCl is not going to react with the impurities. So we can use this information to tell us how much calcium carbonate there was in the shells. So we know that 0,097 mole of HCl was needed to react with the calcium carbonate in the shell sample. Remember that percentage calcium carbonate purity is the ratio between the mass of calcium carbonate and the mass of the whole shell sample expressed as a percentage. So we need to know how many grams of calcium carbonate there are actually present in the shell sample. How do we find that out? We make use of this equation, which shows us how calcium carbonate and hydrochloric acid react with one another. From this equation, we know that the reacting ratio between calcium carbonate and hydrochloric acid is 1 mole is to 2 mole. We need to find out the mass of calcium carbonate that needed to react with 0,097 mole of HCl, since we know that that was how much HCl reacted in this example. In order to apply the 1 mole is to 2 mole reacting ratio to this particular situation, we need to convert it into a mass-mole reacting ratio. So we ask ourselves, what is the mass of 1 mole of calcium carbonate? From the periodic table, we calculate the molar mass of calcium carbonate as 100 grams. So the mass to mole reacting ratio between calcium carbonate and hydrochloric acid is 100 grams is to 2 mole. The question is, how many grams of calcium carbonate must have reacted with 0,097 moles of HCl? We apply a reacting ratio. In other words, we multiply 0,097 moles of HCl by a conversion factor. To be useful, this conversion factor should have moles of HCl at the bottom and grams of calcium carbonate at the top, so that moles HCl gets cancelled away and we are left with what we are asked to find, grams of calcium carbonate. For the conversion factor to be legal, it must in effect equal 1. In other words, top and bottom of the fraction must be equivalent values for this reaction. In other words, this must express the reacting ratio between these two chemicals. 100 grams of calcium carbonate for every 2 moles of HCl. And we find the answer to be 4,85 grams of calcium carbonate. What does this mean? This means that there are 4,85 grams of calcium carbonate inside this shell sample. Not all of the shell sample is calcium carbonate though, which is why the whole sample is heavier than this. It's 5 grams. From this we can calculate the percentage calcium carbonate purity. 4,85 divided by 5 multiplied by 100%. The answer is 97%.